Okay, at 6.6 we get into a little bit more detail about parabolas. 6.5 is more about having an idea of what the graph is going to look like just by looking at the equation, but in 6.6 we want a little bit more detail to our graph. So we still have the vertex form that we saw in 5.5. And you can still use that for all of the stuff that we learned about A, and we know that the vertex is HK. Okay, we talked about that. So you'd shift left and right by H, up and down by K. So it's the same as thinking opposite sign, same sign. Now, in this section, we start looking at the other form, which is standard form, and that looks like this, ax squared plus bx plus c, which we've seen before. So these are just two different forms of a quadratic. The a here is actually the same as the a here. So all of the stuff that we learned about a is the same one here. So if a is positive, it's up. If a is negative, it's down. If a is bigger than 1, it's narrow. If a is less than 1, it's y. So all of that stuff still applies. Now the big difference here is that you can't look at this and see the vertex like you can over here. And the vertex is really the key to a parabola, so we have to be able to find the vertex. So one shortcut that you can take, instead of trying to, you can get this equation into that form, but it can be pretty messy. So a shortcut that you can take is that the h part of the vertex, the x value, is always equal to negative b over 2a when it's in standard form. So you can use the a and the b to find the vertex. Okay, so you do that, and then to find k, you plug it back in. So to find h, get that number, and then you plug it back in to figure out what k is. So you can get the vertex that way, even if it's not in vertex form. And that's generally the quick and easiest way to do it. You can also use a graphing calculator. You can also complete the square, things like that. But this is generally the easiest way to do it. All right, and then for both of these, whichever way, they also add in finding the x-intercept and the y-intercepts, which we talked about way long ago earlier in the semester. Remember, to find the x-intercept, you set y equal to 0 or f of x equal to 0, same thing, and solve. And you may or may not have x-intercepts. So if you try to solve that and you get no solution, that's okay. It just means it has no x-intercepts. You will have a y-intercept. You plug in x equals 0 and you simplify. Okay, so you will always have the vertex and the y-intercept. Always have the vertex and the y-intercept. The x-intercept is a maybe. Okay, so you either need to graph it or you need to try to solve for it to see if you have them. All right, so let's try a couple of these. So let's say that we've got, let's do y equals x squared minus 8x minus 9. Okay, we want to do the vertex, the intercepts, and graph. So let's start with the vertex. We're not in vertex form, so I can't just look at this and know what the vertex is, but I can use negative b over 2a. Here's my a, here's my b, here's my c. Okay, make sure that the a is in front of the x squared, even if it's out of order. A is in front of x squared, b is in front of x, c is alone. And I can plug that in. I'm going to have negative 8 over 2 times 1. That's going to come out positive. 8 over 2 is 4. And then to get the k value of the vertex, I'm going to plug that back in. So I'm going to have 4 squared minus 8 times 4 minus 9. I got some big numbers going here. Okay, 16 minus 32 minus 9. So that's going to be negative 25. Yeah, okay. So our vertex is at 4, negative 25. All right, the other thing that we always have is a y-intercept. And for the y-intercept, we plug in x equals 0. So let's plug that in. We're going to have 0 squared minus 8 times 0 minus 9. So that's 0, 0, negative 9. So our y-intercept is negative 9. And our vertex is right there. Now, if you graph that, you can stop and graph that right there because you know you're going to have those two. You can see if you're even going to have x-intercepts, because if you don't have x-intercepts, there's no point in looking for them. So I need a really big graph this time. Really big graph. Okay. All right, so the vertex is at 4, negative 25, somewhere right about there. The y-intercept is negative 9, right about there. Okay, so looking at this, we also see that A is positive, so it's a parabola up, which makes sense for our information. Are we going to have x-intercepts? Yes, we're going to have to at some point hit the x-axis, so we definitely do have x-intercepts. So we're going to set this equal to 0, and we're going to solve. And what do we have here? We've got a quadratic equation. So you run through all your ways to solve a quadratic equation. If it factors, the easiest thing to do is to factor. Okay, that's the most foolproof way to do this. Does this one factor? Yes, it absolutely does. Factors of 9, that would give us 8. Should be 9 and 1. Okay, they multiply to be negative 9. They add to be negative 8. All right, if it didn't factor, then you could look to see if it was in the form of square root method or quadratic formula, something that, you'd go on to one of your other methods. But this one factored. So we can break this up. We got something times something equals 0. And we get positive 9 and negative 1. Let's see how that looks on our graph. Negative 1 and positive 9. Okay, now before you draw anything in, check and make sure that it's nice and U-shaped. It can't be leaning on its side. It can't be asymmetrical. It can't look all wonky. All right, it's got to be, to the extent of our drawing abilities, it's got to be nice and smooth and even. Okay, and that's about as good as it gets graphing on my tablet here. Should be more like that. There we go. Okay, so you can see that my drawing isn't perfect, but my parabola is nice and centered. Okay, it should be symmetric around the center. So one side can't be over here and the other one over here. It's got to be a nice U shape. Right, that's what you're looking for. Okay, so that's the basic idea there. You're going to look for the vertex and the y-intercept, and if they exist, you're going to find the x-intercepts too. If they don't exist, that just means you don't have x-intercepts. So you can have a parabola with no x-intercepts like that. All right, but you always have the vertex and the y-intercept. All right, let's try one of the height application problems because there's usually questions on that. So let's say that we have a projectile being thrown up in the air according to h of t equals negative 16 t squared sorry, I don't want to do the one that I did in the other video. Let's do plus 72. That should work. Plus 10. Yeah, that should work. Okay, so this is our projectile. So h is the height, and t is the time, usually in seconds for this setup. Just go with whatever units it's given to you. So the projectile is being launched, and it actually follows the path of a parabola. So if you want to know what the height is from the ground, you would have to find the t, and so let's say this is as it travels. Here's t, and here's the height. And remember, if you want to find the high point, if you want to try to find the maximum or the minimum of a parabola, you're actually looking for the vertex. Okay, the vertex is the maximum or minimum. Okay, so let's say part A, what is the height at t equals 1 second? Okay, so the height at t equals 1 second. So if they give you time, you're just going to plug that in. So I'm plugging 1 into h. Okay, so I'm going to plug 1 in. Remember your order of operations here. The square is with the 1, not with the 16. Okay, so I've got to do the exponent, then the multiplication. So 1 squared is 1 times negative 16. 72 times 1. So it's going to give me 82 minus 16 should be 68. No, 66. I knew that didn't look right. Yeah, 66. Okay. So at 1 second, the projectile is 66 feet up in the air. Okay? Part B, what is the maximum height? What is the maximum height? Okay, so maximum minimum, you think vertex. And if we want to find the vertex, we're not in vertex form here, we're going to need negative b over 2a. Okay, and that's little h, not big H height. That's little h of the vertex. All right, so we've got negative b over 2a. Here's our a, here's our b, here's our c. So that's going to give us negative 72 over 2 times negative 16. That's going to come out positive, and 72 over 32 is 2.25. Drat, I wanted that to be a whole number. I didn't do it right in my head. Okay, so that's okay. H is 2.25. All right, now, what is 2.25? Is that our height, or is that our time? Remember that your vertex is hk. So h is the variable and k is the function. X is your variable, y is your function value. So what we actually found here is the time. This is the time that it takes to get to the maximum height. This is not your final answer. You have to plug it back in to get height. Okay, so that's really important, and that's true for all quadratic models, not just this one. So we need to plug that back in. I'm definitely going to need a calculator for this one. Okay, so we plug that back in, and we should be able to get the maximum height. Give me 1 second. Maximum height is 91. And we should be in feet and seconds for this one. The units will be given to you, just go with that. Okay, so the maximum height is 91 feet. Does that make sense? At 1 second, we hit 61 feet, and then at the maximum height, we hit 91 feet. That sounds pretty reasonable. We might need a few more numbers to decide if, for sure, but it seems pretty reasonable. Okay, and then one other thing that they might ask you for these problems is when does the projectile strike the ground? And you kind of need to remember that the ground means that height is 0. So you're looking for height of 0. Okay, sorry, I had to clip out a mistake that I did here. So you're looking for a height of 0. We've got, let me back this up a little bit. Okay, so we're going to take our equation and we're going to set it equal to 0. That's what we're looking for. And this is most likely not going to factor. Regardless of what method you use, you definitely want to look for common factors, and you don't want to have a negative out front. Okay, so no matter what the method is, whether you're factoring or quadratic formula, a negative out front is not ideal. And if we divide everything by 2, it's going to make our life easier. So we're going to divide everything by negative 2. And we're going to get 0 is equal to 8t squared minus 36t minus 5. Okay, so divide everything by negative 2. That's going to change all the signs, and it's going to divide everything by 2. All right, now this is this going to factor? We're running super short on time. I think that it might factor, but I'm going to go ahead and do quadratic formula real quick so we can get an answer. So we're going to have negative b plus or minus b squared minus 4ac all over 2a. So it's going to be 36 plus or minus, and then underneath the square root, that's going to be 36 squared plus, that's 1456 over 16. No, that wouldn't factor. Okay, so we've got 36 plus square root of 1456 over 16. Okay, so I get 4.6 for one of my answers, and then 36 minus 1456 over 18, and I get negative